Hello, my name is Daniel Slovich, and this is my quad drive Rover robot demo. The objective of this project is to create a user-controlled quad drive Rover robot. The user is meant to drive the Rover up a ramp, pause at the top, turn around, and descend using keyboard input. The robot's physical and dynamic properties are set to allow for it to maneuver the ramp. This is a keyboard-controlled Rover. It uses ROS for all inter-process communication and exists within a gazebo simulated world. There are three main elements to this design that we will approach now. First is our robot creation, second is our keyboard controller, and finally is the robot movement. On the left-hand side, you can see a summary of those three main elements that we have used in this design. Our first to discuss is the robot's creation. An SDF model of a four-wheel drive robot is created with a chassis, 4 axles, and 4 wheels. There are 8 total joints in the model. 4 joints control the rotational angle of the wheel mounts, which allow the robot to rotate left or right and to drive in a straight line. The other 4 joints are designed to spin the wheels and drive the robot. Another major design consideration is with the physics and dynamics of the robot. A mass is applied to the components of the robot to provide stability. Wheel surface friction and joint friction is applied to prevent slipping, and the wheels additionally are designed to be semi-soft and absorb shock and provide additional friction. The wheel joint torque must be high enough and velocity low enough to allow the robot to climb the ramp. The second step in our design is the keyboard controller. The keyboard controller is a non-blocking input method designed to continuously read for user input. The user can drive the robot using the WASD keys and can navigate up the ramp, pause, rotate, and descend. The robot and its movements are governed by the keyboard input. Lastly is our robot movement. The robot's movement is perhaps the most robust process within this design. The movement uses multiple services to communicate. It first senses and sets the rotational angle of axles, and then controls the spin of the wheels based on user input. It uses the low-level joint controller created to independently control the 8 joints of the robot model. On the left-hand side, you can see there's many topics, services, and messages used for the robot's movement. With our design considerations complete, we can now begin testing our robot. A package is created to allow all processes to be launched simultaneously. After launching the application, the robot spawns at the center of our world. The user is then prompted with the keyboard control action. As input is read by the keyboard controller, the robot begins its movements. The robot is then guided to ascend the ramp, pause, rotate, and descend. With that, our design components are complete. And from the video, you can see the successful operation of our Rover robot. Thank you for listening.